Hello and welcome back, everyone, to another one-on-one with Jerry Hall. Today's incredible interview is being sponsored by HyperCycle.ai. I'll get you some information on that as we go through the interview today. But let me tell you who we have in studio. Mr. Greg Osuri, CEO of Overclock Labs, founder of Akash Network. Now, the digital wave that has been sweeping through our lives over the last 25 years, transforming our libraries, our physical cameras and books into digital items living on digital networks. This isn't slowing down. This transformation to digital is not slowing down. Matter of fact, it's picking up speed with AI and the sheer abundance of need for computational power. Networks like Akash are bringing a decentralized, non-monopoly version of that. We're all familiar with AWS, Microsoft Azure, Google Cloud, but these are proprietary platforms, right? The same control and risk factors that you would have with any controlled monopoly are at play with them. Not so much with our distributed or decentralized networks such as Akash. Now, as a digital asset investor, I am very keen to projects in the digital asset space that are actually producing a product that is in a vertical that is a real life need. And computational power is absolutely needed, more and more and more of it. We cannot seem to produce enough of it. And AI's requirements on it is only going to get larger and larger and larger. So I thought today was a perfect marriage. This video being sponsored by Hypercycle, and the interview is about Akash. This is going to be a good one. I hope you learn a lot, folks. I know I did. All right, Greg. So great to have you on the show today. How are you doing? Where you're broadcasting from?
Fantastic, Jerry. Great to be here. I am, as of now, based in Austin, Texas, although that is a secret. Most people think I am still from San Francisco, but I recently moved to Austin, Texas. So there you go.
Well,
the secret, no more.
Yeah, I'm from the North Bay also, and I'm down here in Costa Rica. So it doesn't mean we don't love the Bay Area. We're just not there right now.
Yes.
All right. So I have a list of questions I want to go over with you because obviously what you've done with Overclock Labs and specifically this Akash Network project, I've been a big fan. I've been involved at least as a token holder for Akash for the last 2 years. I have been anxiously awaiting its product coming to market, which we're right around the corner from. So let's get into some of these questions. I'll give you a chance to speak. I want to talk about compute, right? I've modeled, when I think about computation and compute, what is it? For me, it's a combination of electricity, hardware, and software. When put together, boom, value or something comes out the other end. How would you describe compute?
The way I would describe compute is essentially a logical abstraction of energy. It is transforming energy, electricity, right, to logic. And there are different layers of that abstraction as we get higher towards this energy being consumed by a user. And depending on where the consumption occurs, at what level, the compute and the units differ and get further abstracted out. So essentially, it is an abstraction, a logical abstraction of energy.
Interesting. So it would be too simplistic to think that all compute is going to have one unit of measure, like electricity has a unit of measure of a watt, kilowatt being 1,000 watts, et cetera, et cetera, et cetera. Compute could have a variation of different metrics to use to describe its unit of measure for whatever context it's being used in.
Correct. There is a good degree of heterogeneity at every layer of the stack of consumption, that commoditization of this stack is nearly impossible. So the unit is contextual to the usage layer or the use case.
Interesting. So as a company producing the product of computation, right? This kind of term, it could have pricing in many different tools of measurement, unit of measurement, depending upon what the use case of it is, versus like if I'm going to run a validator, that may have one kind of consumption model. If I'm going to run diagnostics or maybe just crunch numbers like a mining thing, that would be a different kind of compute. Therefore, it would have a different pricing model with a different unit of measure. Interesting.
Right.
Wow,
It starts with
okay.
a data center, which is still measured in kilowatts and megawatts. So data center's capacity is the electricity capacity. That's the unit of measurement. But
Oh,
as you start putting more, abstractions, more layers into this data center, be it a rack, that's measured in use units, right? Then you get into like, actual compute and CPUs that's measured in clock speed, and then you get into like different layers, be it GPUs that's measured in teraflops, and then you get into the actual abstraction, like for example, Bitcoin is measured in by the encryption algorithm, the unit of the what do you call the benchmarking unit for that encryption algorithm, right? Be it essentially hashes, right? So at every layer of abstraction, you have a new set of units that you measure the abstraction's performance, or you measure the abstraction's capacity by.
wow, thank you. That was very informative. I bet will come back to this piece of the recording several times. So with that answer, then looking at computation as a commodity is too simplistic.
It is.
It's too
And
simplistic. Okay.
it's very simplistic because the well, simplistic as a whole, but it can be commoditized depending on the abstraction, right? So what that means is, if you are mining Bitcoin, you can commoditize in hashes because ultimately that's what matters, right? So ultimately, it doesn't really matter what kind of hardware, what memory, what GPU it has. Ultimate unit of measurement is the hash for a Bitcoin mining link. So yes, at that level of abstractions, it's a lot more simple, but the lower you go in terms of abstraction, it gets more complex. That cannot be commoditized. So I cannot not say it cannot be commoditized, but it can be depending on the level of abstraction. But to say the all layers of compute is commoditized is not a fair assessment.
Wow, very interesting. So that my next question rolls right into this. How do you see the marketplaces for such materializing if there is no base unit like a gas station where you go in and it doesn't matter what car you bring in, you're going to pay this amount per gallon, right? The commodity is
Right.
the gasoline and you're paying for it regardless of what you're putting it into. But that seems to be flipped on its head with what you've just described to me. So how do you see these either monopolized or even open source or decentralized or distributed marketplaces providing this kind of new product?
It gets very complicated. That's why a marketplace like Akash, which has a heterogeneous, model versus something like a Filecoin, which has a more homogeneous model, right? So specialized compute can be easier to measure, even though that may not be completely accurate, but you can get, accuracy to a certain degree, even though there are variances in storage. The speed or the latency of reads and write could vary depending on the storage, but you still measure storage in bits and bytes, right? So ignoring other aspects and other properties, which could be crucial depending on the use case. So specialized compute platforms, the specialized, the higher the specializations, easier to measure, right? So So Filecoins of the world are much easier. When it comes to Akash, it's very hard. So we come down to revenue essentially as the only way to measurement, which is not a great way to measure because revenue could be variable. But unfortunately, we don't have a single metric you can go measure by. So we take one way to look at it is you take the most resource constrained aspect and you go with that measurement. So in typical compute, it's generally memory. Right? So memory is a lot more expensive than disk and a lot more scarce. Right? So you go by memory, right? Again, but you can't just have memory because then you're not optimizing for CPU workload. So you cannot have a single unit of measure. So you have to have a multi-vector measurement mechanism. And so it's easier when you have something like GPUs where your measurement is basically teraflops, right? So even though that's not fully accurate because the memory of the GPU matters quite a lot for what kind of AI model it can train. Like sometimes more teraflops does not necessarily mean it's faster. Like AMD is much faster than NVIDIA, but NVIDIA still has 80% market share. So do you go with on-chip memory? Not really. AMD, some of the AMD processors have 120 gigabytes of memory, whereas NVIDIA H100, the most advanced chip, has 80 gigs of memory. So it's very hard to measure heterogeneous models, heterogeneous marketplaces, because you cannot have an order book that has homogeneity introduced, right? So I don't think we will ever have a way to measure heterogeneous computing. That's not the way. You're never going to have a way to measure diamonds, for example, right? So diamonds are going to be variable. It's like, whatever the 4Cs or whatever they call that, right? So you have these different properties of a diamond and each diamond is placed. Now you can create cohorts based on homogeneous properties, but the liquidity is going to be so low in this cohort that you may not get accurate price accuracy. So that's why Akash doesn't have a matching engine. It has a bidding engine. So it really comes down to the user to select the provider because the variability is incredibly high. There presents other challenges in terms of liquidity, but yeah, the variability is so high that the system and the protocol cannot decide on behalf of the user. Whereas any protocols that do that on behalf of the user generally don't perform as good as anticipated because the user's needs are so variable and it's very hard to read someone's mind, right? So yeah, it's a big challenge for decentralized compute, but happy to talk about ways we're trying to address those challenges as well.
Well, it leads me right into my next question, which is, what is the value of distributed / decentralized networks versus, and I just call them the big three, right? They're the evil empire of Amazon Web Services, Microsoft Azure, and Google Cloud. These monster corporations that are that I have no way to participate in its value other than what I abstract from it as a customer.
Right.
But what you guys are doing is a completely different deal. So please, you have the floor.
Yeah, if you think about it, right? So original design of the internet was decentralized at core. Right. The point was to create a network that is resilient to various attack vectors, be it primarily a state level attack vector, to have an undisrupted communications platform. That was the original goal of the internet. And as we evolve in complexity of applications, different topologies of applications being deployed, we transition from this very decentralized network to hyper decentralized networks, right? We're talking about hyperscalers, essentially few companies controlling about 80% of the market, right? Or 80% of compute. So that invariably leads to challenges that oligopolies come with, like big challenges. They stifle innovation quite a degree. And we saw that with airlines, we saw that with telcos, we see that with pretty much any oligopolies. The moment you have few players that have too much control over an industry, they stifle innovation, they prevent new innovative players to come into play. they gouge prices, they essentially, have very little incentive to put the user's best interest versus a corporate or shareholder's best interest, right? So you get into this like massive inefficient layer, which is seemingly the most important layer for modern society. Cloud is the fabric that connects humanity, especially as we're entering into this hyper computational mode where AI is playing a bigger role in our lives on a day-to-day basis. And now, if you're telling me the gatekeepers of this AI, which is essentially the people that have GPUs, are someone that has their shareholders, interests at their heart versus the consumer of the society or humanity as an interest in heart, is troubling for me and a lot of us, right? So the promise of decentralized network is to reverse that hyper centralization and put people that use the cloud as in charge, and by giving them the ownership and equity in to participate in this cloud, right? So now that comes down to like the profits and the open source and all the great things, but fundamentally it is about people first versus a shareholder first. So a corporation is going to optimize for corporation, community is going to optimize for. That's why decentralization leads to communal public utilities, right? And if you consider cloud to be a public utility in the sense that it has public at its interest and not profit, it is very, very important that it is decentralized, because there is no other structural primitives that we have besides decentralized networks, right? So that's why decentralization is very important. And the benefits you get is obvious, right? So with Akash Network, you get both a advantage when it comes to cost. In some cases, it's 80% to 70% cheaper than what you normally would pay for a traditional cloud to access, right? You can get chips on Akash now with GPUs that you cannot get on the cloud. And that is what an open network will bring to the table in terms of reach and access, right? So there are incredible other benefits with open source and all that good stuff. But fundamentally, it is about people first versus a corporation first.
I like it, and it really sets the foundation and stage for actual free market capitalism to take place, right? Good job.
Yes.
Good job.
Yes.
My next card does not even need to get addressed because you already answered it. What I want to get into is something specific to Akash. Now, I'm seeing this on Twitter. I'm seeing this a lot on X, and that is the AI super cloud is coming on Akash very soon. So I want to get into that, but before we do, I'm seeing, like, for instance, I'm deep into the Cosmos verse, and I use a product software called Restake. And I see Restake it says right on the bottom, powered by Akash. I'm assuming Restake runs all of their software on Akash computational power.
Yes. I mean, a good portion of Cosmos ecosystem runs on Akash. I would say like at least 40% of Cosmos projects use Akash to a certain degree, right? At various levels, because because of its closeness, and Akash being the first Cosmos chain that connected to the Cosmos hub. And also the experience is geared towards a community that knows how to use Kepler and a whole lot of things. So it's very closely aligned to the Cosmos ecosystem. And we're one of the core contributors to Cosmos as well. So that puts us in a special place with Cosmos. And we take a lot of pride in that, but I think our bigger use case is really in AI and machine learning. So to answer your question, what is AI supercloud? So before that, let's take a step back, understand what a supercloud is.
Okay.
So my background, I began with working on cloud native or this problem in 2014, 2013 timeframe, when it was very obvious cloud is going to play a prominent role in the future of compute. So it was not very obvious to the world, but for us folks that were in the industry, that understood the benefits and the trade-offs of the cloud, um, categorically came to a conclusion that cloud is going to be an extremely important, if not the most important layer of humanity, right? And that brought along with concerns of hypercentralization. So we've been thinking about this problem for a very long time, both in the industry as well as academia. From the industry, there was this new set of technologies called container native technologies that were brewing, called Kubernetes or Docker and all these terms you hear. And this is in 2014. They were kind of forming, and I was very deeply involved in this development of these tools. Written code that's used by Docker, Kubernetes, Terraform, a whole lot of things, till date actually. And in some of the and in the idea that, hey, we need to create a higher control plane that can supersede the cloud, and that is open source and that is transparent, was getting popular. And I think it was Cornell University that the term that the created the term supercloud. The idea of supercloud was, well, hey, if we can minimize the cloud or any compute provider to a resource provider and move the control plane, be it all the critical functions, be it orchestration, fault tolerance, access control, observability, all the critical functions you would need as a cloud practitioner to a higher plane that is open source, it will prevent you from getting locked into a single provider. It'll reduce a dependency on a single provider. It will essentially reduce the provider to just a resource provider, and that way you have the freedom to operate across different clouds. So the idea was the super cloud was getting just being planted around that time frame, and we loved that idea. We thought that was a way to reduce a dependency by reducing the responsibility of the cloud provider. It's very obvious, right? So by giving those freedoms, we essentially theorized this super cloud idea in 2018 in a white paper called Akash Network we published. We introduced the idea of a super cloud, and we introduced the idea of what a decentralized marketplace for the super cloud essentially will take the concept further and even reduce the cloud providers even further by spreading by enabling anyone to become a cloud provider on the network, right? So this way, let cloud providers do what they do, be any provider, which is provide compute. But if there are people that are not the big three, they can as well participate in this network. And now, super cloud, if you Google, it's a very popular term. It's a lot of people talk about it, but we were the first ones to introduce the idea of what a functional super cloud would look like. And Akasha believes the only super cloud, as far as I know. We obviously built and launched the network 2 years from the time we said we're going to in the white paper. Around 3 years, the Akash Network has been live, and we have this is a sixth upgrade we're doing, mainnet 6, right? So there were 5 massive upgrades, and upgrading decentralized networks are a Herculean activity because we have no control over any of the servers, and we have one, model provider that we experiment, but about 50 providers on Akash Network, all of them need to be updated and need to be coordinated and all that crazy stuff. So yeah, we built the first decentralized supercloud, and now with GPUs, you have machine learning, right? So that's where the AI supercloud comes into play, because for the first time, we are sort of like verticalizing the supercloud to machine learning. What that means is you're going to see more workflows that are going to be optimal for machine learning to use Akash Network GPUs. You're going to see the right type of GPUs that you may not get on the cloud itself, like H100s and A100s that are impossible to get today on Amazon, Google, and Microsoft, available on Akash. You'll be able to get to new type of GPUs that you may not have access to, right? So there's a whole movement right now happening with with instead of going to the GPU, bringing the GPU to you, right? So there's enormous GPUs around, that are beyond NVIDIA, right? So we're talking about AMDs, we're talking about Intels, we talk about a wide set of GPUs that are available. All of them can perform floating point operations, right? Flops basically pretty well. And the only thing that's missing is the SDK and the connection to these GPUs, right? And a decentralized network can go places where a centralized cannot, right?
Right.
That's what makes decentralized networks extremely great. So Akash can go to a PlayStation, Akash can go to a refrigerator, Akash can go to anywhere a GPU exists and essentially bring that GPU to you using GPU over IP techniques, right? So this super cloud idea is going to, well, start with data center GPUs because that's where the most demand is at present. But as we go about deploying these data center GPU workloads, introducing them to additional type of GPUs will open up doors to call it innovation beyond imagination. Like, what can you do when you get access to a million GPUs that have significantly lower cost than what you would normally pay to either buy them or lease them elsewhere? And what happens if you can bring those GPUs to you using techniques that are being brewing right now? And what is that? What kind of products will you be able to build? And top of my head, there are enormous use cases that are currently being limited because of lack of GPU access. Like OpenAI, Sam Altman, they make $1 billion this year. They are limited from making more money because they don't have access to GPUs. And that's a real problem, and he was very open about that. And we have one of my best use cases for machine learning is healthcare, like diagnosis, right? Yeah. There's 8 billion people in the world, with most of them don't have adequate access to healthcare. Why? Because there are not enough doctors. Why? Because there's only a limited set of patients a doctor can see. And most of the time, a doctor is diagnosing. What that means, they're recollecting what they learned in med school by looking at your lab results. And they're making the best guess in terms of what, in terms of coming to a conclusion with the diagnosis, right? Guess what? AI can do recollection way better than a human being. Yeah. So using AI, we can empower doctors. If a doctor is able to see 10 patients a day, they can now see 100 patients a day. Imagine what that future will look like. And last thing I want is you go to a doctor and that doctor is unable to see you because he doesn't, or he or she doesn't have access to a GPU. That is not okay in my book. And that's what AI Supercloud is going to bring you. It's going to bring you use cases that can go beyond what a regular cloud can, because a super cloud can go to places where a cloud cannot. And that's the promise of the super.
That is so incredible. I liken it to, this is how the analogy played out in my head. So I distinctly remember listening to my great-grandfather talk about how many acres he could plow with his ox, and how incredible it was for him when he bought his first tractor. The same farmer increased his productivity tenfold just by that one new device in that ecosystem. And so what I'm seeing with cloud, the ability to, like the AI supercloud that you're discussing, the ability to do more, harder, faster, better, is going to take us to, it's going to be a new industrial revolution. It may not be mechanical like the last 100 years. It will definitely be digital. And you're in a prime spot. And I feel we here at Hypercycle, exactly the same type of place, where how can we get computation into the hands of more people so they can do more things? As each new entrant to any network comes on board, they add value to every other entrant, existing person in the network. I love that whole progression, what we call it Metcalfe's law, right? When you start thinking about how networks get more valuable as they grow with new entrants and new capacities. Hi, folks. Sorry for the interruption, but I wanted to pop in and just tell you a few things about this incredible company I'm with, Hypercycle. First and foremost is that you can find them at hypercycle.ai. Now, what Hypercycle is doing is they're creating a distributed network for AI agents to contract and pay for work amongst themselves. This computational power with this software is going to produce incredible results for the ecosystem, but also for the participants. Now, the main way for you and I, unless you're an AI programmer, to contribute and actually take part in this network are to become node operators. So I want to leave you with this little 2-minute video that explains what a hypercycle node is. All right. For more information, please go to hypercycle.ai.
A hypercycle node is a software enabling the smallest AI modules to interact and transact with any other modules efficiently and securely due to its cryptographic proofs and true P2P design. Hypercycle computation node is comprised of loosely coupled components, mainly a virtual machine, a transaction machine, and an AI machine. In order to operate, the VM machine must receive a 3-way input composed of, first, a SATO server, which is represented by the HYPC token and acts as a cryptographic proof of conditional payment wrapped in sufficient cryptographic proofs within a 64-kilobyte file packet. Second, the exact data in need of AI computation such as images, text, or audio. Third, the smart contract instructions on how to process the data. Once the virtual machine has received the complete required input, it then acts as an interface between the network and components of the hypercycle computation node. Once the HYPC, aka the SATO server, has been confirmed by the transaction machine, the TM, only then the instructions are sent to the AIM along with the data to be computed. Each node will run its requested part of the AI algorithm on the chunk of the data it has received and return the results to the network, so the proof of the work can unlock the payment it has been committed to it. Effectively, another hypercycle computation node. The hypercycle node will then aggregate the results from all of the nodes and the proof of payment within milliseconds and output them to the requester via the virtual machine. This unique design brings forth the manifestation of exponential collaborative efforts between AI agents, undoubtedly leading to the emergence of a new overall intelligence between nodes using AI computation at large scale. Thanks for watching. For more information, visit hypercycle.ai.
Let's back up for a second. Let's talk about what these GPUs are, right? So not all GPUs are equal, right? Each GPU, the demand for the GPU depends on the density of the GPU generally. So if you are someone like OpenAI, who's developing, arguably the best and most advanced model, LLM ever, GPT-4 and GPT-5, you will need the latest and the greatest chips because the difference is the time it takes to train, right? So in some cases, the latest chip is NVIDIA H100, which is made by NVIDIA. And the next best chip is A100, 80 gigs, which is also made by NVIDIA. The difference is 9 times faster.
Wow.
So it took about 3 years to train GPT-4 from GPT-3. So GPT-3 came in 2020, GPT-4 came in 2023. So that was done on A100 stack. So GPT-3 was one, and also and another important parameter you need to know is parameters. Like how many parameters does a model have that dictates how long a model needs to be trained, right? So GPT-3 is 175 billion parameters. That took a long time. GPT-4 is believed to be 1.1 trillion parameters. Right? So it is literally a massive large language model. Yeah, it's huge. And so if you're training on a slower cluster, it's going to take you ages, years. Right? So you need the fastest and the greatest chips. And that is a big bottleneck today. To get an H100 from NVIDIA, it takes about 2 years directly. So, and your next best way to get NVIDIA is through distributors, Dell, Supermicro. It's about a year, 6 months, depending on what kind of relation you have, depending on what your order size is. They're so hard to get. Even Elon Musk is unable to get them. Like they bought about 10,000 H100s not too long ago, for $300 million, I believe. And they are using H100s to train the new FSD for Tesla. And it is, but their models, I believe Elon said this morning, it was 3 times faster than A100. So again, the speed is completely dependent on the model that is being trained. So bottom line is, it's the more advanced the chip is, the harder it becomes to get them. So as a startup, it's impossible for you to go to NVIDIA and be like, give me some chips, because each chip also costs about $40,000, each 100. So typically, startups are used to go into the cloud to get demand compute. Guess what? Cloud does not have H100s. Why? NVIDIA did not give them. Why? Because NVIDIA considers these cloud providers to be competitors. Because at one point, if you remember, Google has TPUs, or tensor processing units, which are chips essentially competing with NVIDIA H100s. Amazon, Microsoft, similar efforts they were making chips at some point. So NVIDIA is very, very aware and are optimized to remove power from the big guys. This is what the dynamics happen when you have over centralization, right? NVIDIA is going to look out for itself and not going to look out for its customers, quote unquote, but they are actually doing better than the cloud in a way, because they are distributing the chips to smaller providers, be it CoreWeave, be it Lambda, be it, DataCrunch, be it a whole lot of the 20 others, right, that are getting the chips much faster than Google. So CoreWeave has about 35,000 H100s, way more than Google ever has H100s. I believe Google is going to introduce H100 soon. I haven't caught up with the event yesterday, but there are rumblings. But anyway, the point is, as a startup, you cannot go to the cloud, and you got to go to the secondary or a smaller regional provider, and you go to them, you're not going to get them on demand. You are going to need to get into a long contract, usually a year prepaid contract. And if you're a startup company, it is very hard to understand your capacity. It's very hard to pre-plan for a year. The younger the company, because your variability is so high, and your iteration is so high that you cannot for sure know how much capacity you need. So a lot of them are just buying up these chips or getting to the long contracts, without which they don't have access to the chips, or else they have to wait 6 months. There's no on-demand option. So our best customers, our best providers are these companies that get into the long contracts with some of the cloud providers and want some relief on the contracts. And putting those chips on Akash is a great way to get it.
Love it.
So Akash is a secondary market. It is like Airbnb. So it is essentially you're leasing, you need an apartment because you cannot find a hotel, especially when there are events in the city like New York City and whatnot. You'll get an apartment for a year because there's no other way to get them. And now what do you do like 11 months of the year when you're not in the apartment? You lease it out. So, and second big way Akash gets chips is from professional data centers that are not essentially optimized for machine learning, but have quite a lot of crypto mining chips, right? These are large data centers, 20,000 units, and some of them even have 500,000 units, and quite a lot of these GPUs everywhere. And third is professional miners, so home operating systems that are designed for mining, crypto mining. All were doing Ethereum proof of stake, proof of work quite a lot. Now have no way to do that. Essentially no profits in Ethereum. So now switching over to machine learning and using Akash to offset that. Now they're not the greatest in the most advanced chips, but they do have a purpose. They do have utility, right? And we have that as a supplier. And fourth, we have machine learning companies themselves that have hardware, right? So a lot of these guys, they've been around for quite a lot of time. Like machine learning was popular, say like 3-4 years ago. So there's quite a lot of like already existing chips that people bought, like A100s.
Yeah.
But now they all want H100s because the training time is 9 times faster. Now, what do you do with A100s? Now you can't sell them, and you can essentially, you know, not it's not in your best interest to sell them. Actually, the price is very low, right? So it's almost actually advantageous to have your own data center because depreciation is a tax write-off. I don't know if you know, like, so you can actually, if you're way more profitable to run those chips at depreciation and use depreciation and lease them on Akash, right? So you can get quite a lot of benefits doing that way. And then you have fifth type of provider, which is arbitragers. Like they're like sitting on these like chips because they know the value of the chip is going to be higher. CoreWeave was able to collateralize some of those chips and get get leverage.
Yeah.
So there's quite a lot of arbitragers in the play, and that are playing. So we have different type of providers that are all very unobvious type of providers that are on the Akash network.
Well, it makes a lot of sense specifically from a game theory perspective, right? I mean, if I'm somebody who had a capital expenditure of X dollars and I'm depreciating that, over the course of my 5 years or whatever it is, and there's a marketplace, there's a market out there saying, hey, you have a precious resource. We want to rent it from you or use it or what have you. Who am I to not make a dollar on it? I mean, it just, so no, that makes a lot of sense.
And the tax benefits on top.
So yeah, exactly.
It's very advantageous, like for you to actually rent the chip versus sell the chip, because then you pay taxes on the sale.
Right. No, I love that.
Yeah.
You're right. That was unobvious. That was unobvious to me. Let's talk about for a minute how the Akash token, the AKT token, works in the Akash model here.
So Akash is a layer 1. It is an independent blockchain. Being infrastructure provider, it was very critical, and it is very critical to ensure stability and reliability and availability of the network. So we have to build a layer 1, and it is based on Cosmos SDK, which is a software development kit that allows you to build layer 1 blockchains. And the consensus mechanism is proof of stake for obvious reasons, mostly for energy, conservation reasons and efficiency reasons. And proof of stake requires a token as the core unit of consensus.
Yeah.
Without a token, there is no blockchain, there is no Akash network. And token is used to secure the network, which is its primary function. Token is used to gather votes for evolving a community, Akash being a completely open network. Not only the software is open, but also the process of building the software and the funding is also open. Anyone can build software in Akash. There is a set of self-organizing community groups that meet regularly. In fact, I have a meeting right now in 3 minutes I have to go to. That meet on a regular basis and discuss different aspects of the software. And these meetings are posted on an immutable ledger, Arweave, for which the notes are extracted and published, as well as a summary extracted and published, so people that miss the meeting can go back and read. So we make it extremely efficient for public coordination. And every feature on the roadmap is thoroughly put in a public discourse, conversely, conversed about and debated about. And the process is also being open, is rooted in, merit rather than preference. So all that governance happens using an AKT token. Every spending proposal goes on the chain. We have 200 some proposals, right? So very healthy or functioning governance system. And third is Akash is the unit of exchanging value. So you pay for compute using AKT tokens. It is obviously a great system. It has different properties, streaming and whatnot, escrow capabilities and whatnot. But the big trade-off is the volatility, which is not ideal. So it's good for short-running jobs, but not so good for long-running jobs. So that's why we introduced the notion of a stable currency to pay with. But since that undermines the AKT's utility, which is critical to security, by the way, because the value of AKT is directly proportional to the security network.
Right.
The lower the value, the less secure it becomes, susceptible to bigger attacks. So there is a value extraction mechanism if you're using non-AKT for payment. Means you pay a fee that goes to secure AKT, goes to the security budget to incentivize AKT stakers. And fourth core utility is incentives themselves, right? So Akash need to evolve. That means it needs people building on Akash Network and evolving the network to obviously build and make it more usable, right? And Akash, being 3 years old, is a very young network. It is very powerful, but nowhere as powerful compared to the traditional cloud. And building to parity is done in the open, and the funding for which, the incentives for which also come from the network. And further incentives are now being designed for providers and tenants as well to make it extremely attractive to use Akash. And so without AKT token, without those incentive mechanism, it becomes extremely complicated or near impossible to bootstrap it. So AKT plays a very critical role in all these 4 key areas, without which Akash Network will not exist.
This has been an incredible conversation. I've learned a lot. I'm sure the viewers have learned a lot. I will make sure in the notes, everybody, that you see where you can find Greg. Sorry about that. I will make sure in the notes section, everybody, you'll be able to find Greg on Twitter. He's quite a tweeter. And also where I can direct you to Akash information, whether it be their website. And there's a lot of incredible articles about Akash, either through Medium or a lot of the other blogger type milieu. So with that being said, Greg, thank you so very much for your time. And maybe you'll be gracious enough to come back in the future and keep us updated with what's going on with Akash and Overclock Labs.
Love to. Thank you so much, Jerry, for having me. This was wonderful.